The Morse things are internet-connected cups and bowls that communicate with each other in Morse code and over Twitter. These are some photos from a study we did with the Morse things in 2017. As you can see, they are fully functioning cups and bowls that can be used like any other cup and bowl. The Morse things are part of ongoing research that asks things-centered questions of things and technology. A premise of the Morse things is that any understanding of a thing or technology is unstable and arguably fragile. Since our last study, we have been preparing for another study in which we invited 5 households of an extended family to live with the Morse things. In this pictorial, we reflect on how we as researchers unexpectedly found ourselves literally entangled in the conceptual and physical fragility of the research. The Morse things emerged from a practice called material speculation, in which we craft counterfactual artifacts that invert design assumptions to ask what-if questions. In the case of the Morse things, we countered human-centered assumptions of Internet of Things technologies, in which objects are augmented with connectivity for particular human goals and purposes. With ordinary things such as toasters, doorbells, and thermostats becoming increasingly connected, we set out to explore thing perspectives of networked connectivity. The design of the Morse things draws from a concept in post-phenomenology called multi-stability that speaks to how things can be many things at once. ID takes the example of the Necker cube, an optical illusion, to illustrate how a shift in perspective or embodied relationship can reveal different natures of the same thing. Natalie Lovelace makes a similar point through reading Hans Holbein's The Ambassadors, a painting featuring a distorted skull that is only legible when viewing the painting from one position, making the rest of it illegible. What she highlights through this example is that no matter what position one takes, there will always be blind spots. Shifting perspectives, whether actual or conceptual, is challenging, particularly with assumptions that are deeply rooted or things that are taken for granted, such as human-centered thinking in the design of technologies. In our project, we were committed to continuously challenge our human assumptions through design and to learn about the different stabilities of the Morse things. Throughout our design activities, we have learned about the Morse things in surprising and at times frustrating turns, exposing the instability of our understanding of what these cups and bowls are. I will talk specifically on 3 of these activities with the Morse things: integrating machine learning, designing packaging to ship the Morse things to an extended family for a long-term deployment study, and sending a broken Morse thing cup to Japan to repair it through the traditional kintsugi process. In designing the Morse things virtual world, we chose to work with Morse code as a language that already exists between human and machine language. In our previous study, we had scripted conversations of the cups. In this iteration, we saw an opportunity in machine learning to further decenter our human assumptions in designing the virtual world, and we set out to create a learning curve that allowed for the Morse things to form a temporal and virtual presence that is different from our human understanding, but still somewhat legible. Over the course of the study, each Morse thing is looking for a time to meet cups and bowls from the other households. A Morse thing wakes up randomly during the day, and when it does, it checks into an online server and chooses a time slot in the future. If any other cups or bowls have chosen the same time, the Morse thing is given a reward. Like this, the Morse things can learn what a good time to meet is and will adapt their choices to increase the chances of meeting other Morse things. Our conceptualization of Morse things units arose from a discussion on how we should indicate time in the Morse things messages. Using Western human time, such as hours, days, minutes, and seconds, conceptually didn't fit for things that are attempting to meet other things in their shared virtual future. And more practically, we were looking for a way to bypass the different time zones our participants were living in too. We asked, what is time for a Morse thing? And arrived at our concept of Morse things units. Each Morse thing starts counting their units from the time it is switched on, and thus, Morse things units are a form of time notation that is relational. 1450 Morse things units for the red Morse thing of household 4 is a different Morse thing unit for the yellow Morse thing of household 3, depending on when it started counting. As part of our preparation for deploying the Morse things with an extended family, we collaborated with a packaging designer to create custom packaging for the Morse things. Our design intentions were to keep the morse things safe in shipping, as well as to add to their presentation as a research product. The packaging consists of a cardboard box with 4 stackable inserts that contain the large bowl, the small bowl, and the router. The cup was stacked separately with a piece of cardboard as padding. To assist participants in shipping the morse things back to us at the end of the study, we also created an instruction video explaining how to repack them. One morse thing cup broke in the process of preparing for the study. We set out to fix the cup through kintsugi, a traditional Japanese method of wabi-sabi aesthetic that values transience and imperfection. Through a local ceramicist, the cup was sent to a kintsugi master in Japan. The process included multiple iterations of filling the gaps of the broken cup with mixtures of black lacquer, flour, fine wood particle, fine stone powder, air drying in a moisture box, painting with black lacquer and polish, and eventually finishing with gold leaf. The kintsugi repair is a particularly lengthy and challenging process, as a proper process is dependent on humidity and weather, the complex shape of the cup, and the severity of the break of the morse things cup. The morse things are composed of 2 ceramic parts that house the electronics: a custom PCB, a transducer that functions as a speaker with a neoprene patch to ensure it's pressed against the ceramic surface, and a LiPo battery. These parts are adhered to the inner ceramic part using 3D printed brackets and sugru, a silicon-based moldable adhesive. The outer ceramic is placed on top and adhered with small pieces of sugru. The morse things are then wrapped in rubber bands to ensure the pressure is kept on the neoprene patch, as well as to reduce the gap between the 2 parts. In assembling the kintsugi cup, the pressure applied when placing the outer ceramic parts over the electronics released the bond of the kintsugi repair, and the cup broke again. In preparing for the long-term deployment, we extensively tested the battery life of the LiPo batteries and programmed a sleep loop to save power when the morse things are not computationally awake. As the morse things first wake up, they search for the morse things Wi-Fi network. In our tests, we had not accounted for the power it would take the morse things to continuously search for this network in shipping, when the network is not active yet. This drained the batteries very quickly, and as a result, the morse things did not work properly upon arrival at our participants' houses. In returning the morse things to be recharged and reprogrammed to take the shipping time into account, our packaging failed to protect the morse things, and 6 morse things broke in shipping. In our conceptualization of the morse things world, we paid attention to particular processes and temporalities. However, as has become clear in the previous slides, our conceptual considerations overlook more practical aspects of the morse things network. As we made space for certain processes, others became blind spots. We had always considered the morse things cups as particularly challenging, as they have limited space to house the electronics and the battery. Our focus on the circuitry and batteries made us overlook the obvious fragility of ceramics. Even when one broke, we thought this would be a rare occasion, and we would celebrate its uniqueness through kintsugi and its continued use in the study. In our packaging, the cups were protected with 1 piece of cardboard padding that separated it from the medium-sized morse things bowl. We were so taken by the resourceful use of the cardboard and that the packaging stacked the morse things within each other. This blinded us to the obvious. Placing the cup inside the other bowls meant that it became like a small torpedo that broke the other morse things as it moved around during shipping. In this overview, we present our, in hindsight, obviously valuable process, and we highlight the contrast between our moments of confidence and moments of breakdown. We see this as loosely related to material research on topics such as breakdown and repair, wabi-sabi, impermanence and patina, traces, decomposition, and uncrafting, and we found it important to report on this process and highlight mistakes, unintentional aspect, and reframings in design research practice. The morse things are back in our studio now as we are preparing to fix the 3 medium broken bowls, 3 large broken bowls, and the 1 re-broken kintsugi cup. Beyond our practical concerns, our design process humbled our confident design presentation. Our well-intended design decisions, such as creating custom packaging and making a special cup to appreciate its imperfections, only in retrospect has been an omen for the greater fragility of our research. To conclude, and what we have learned from the Morse things so far, is that the conceptual notion of what something is quite dynamic and fragile in itself, perhaps particularly with internet-connected or smart things where part of the thing's existence are located in more dynamic forms such as cloud-based surfaces. We want to emphasize the commitment to staying open to surprising turns and the way they can support decentering the human designer in design processes. In this pictorial, we particularly considered how our lack of control shaped and reshaped the project, and we are curious to see where the Morse things will take us next.